Right now, as you sit here, the Earth is spinning at over 1,600 kilometers per hour. At the same time, it's racing around the Sun at 30 kilometers per second. But the Sun itself isn't fixed either. It's hurtling through the Milky Way at 230 kilometers per second, and our entire galaxy is orbiting the center of a massive cluster of galaxies. All of them are spinning together like gears in a cosmic machine. Every planet turns, every star rotates, every galaxy spirals. Even the smallest particles, electrons, protons, quarks, carry their own intrinsic spin. From the tiniest atom to the grandest supercluster, rotation is everywhere. But why? Why does everything from dust to galaxies spin? What started it all? Was this cosmic rotation built into the very birth of the universe itself? If we could rewind time to the first instant after the Big Bang, would we find a spark of motion already there? Would we find a twist written into the fabric of space from the very beginning? Today we'll uncover how this invisible force rotation shaped everything we know. The orbits of planets, the birth of stars, the stability of galaxies, and even the magnetic fields that protect life on Earth. This is not just about motion. It's about one of the most fundamental and mysterious patterns in nature, because the universe doesn't drift quietly through space. It spins. Right now you're moving, even if you think you're sitting perfectly still. Look around. The room seems quiet, unmoving. But beneath you, the Earth is spinning once every 24 hours. It turns eastward at 1,674 kilometers per hour at the equator. That means that in the time you've taken a single breath, you've already traveled nearly half a kilometer through space without even realizing it. The moon doesn't stay put either. It orbits Earth once every 27 days, moving at 3,600 kilometers per hour. It is locked in a gravitational dance that has lasted for billions of years. Together, Earth and Moon revolve around the Sunday. They race through the solar system at nearly 30 kilometers per second. That's fast enough to cross the entire diameter of Earth in less than 7 minutes. But even the Sun is far from stationary. Our star is one of hundreds of billions orbiting the center of the Milky Way galaxy. It completes one full revolution every 230 million years. It travels at 828,000 kilometers per hour. And the Milky Way itself isn't resting either. It's being pulled toward a massive region of space called the Great Attractor. This is a gravitational center surrounded by thousands of other galaxies. All are moving together through an invisible current of cosmic gravity. When you look up at the night sky, you might think the stars are fixed, scattered on a static dome, but every one of them is moving. Some move faster than bullets, some slower than glaciers. Their paths are twisting and intersecting across millions of years. Even the constellations we know today are only temporary. In a few 100,000 years, Orion, the Big Dipper, and every familiar pattern will be gone. Their stars will be dispersed across the galaxy's endless spin. And beyond our galaxy, there's more. The local group, a cluster of more than 50 galaxies, is itself rotating. It is drifting toward the Virgo supercluster, a massive structure that spans over 100 million light-years. And all of this, every star, every planet, every galaxy, is part of an even greater system. It is a cosmic web, still expanding, still in motion, since the moment of the Big Bang. So when we say our world is spinning, we're not exaggerating. We are passengers on a moving planet orbiting a moving star inside a moving galaxy. We are racing through an ever-spinning universe that has never stopped turning. It's a humbling thought. Even when we're standing still, we're already traveling faster than we can possibly imagine. Motion is not the exception. It's the default state of existence. We've seen that everything moves from our spinning Earth to the vast galaxies drifting through space. But have you ever wondered why they spin at all? Why doesn't a planet just form perfectly still? Why can't a cloud of gas collapse into a quiet, motionless ball? The answer lies in one of the universe's simplest rules: motion never disappears. It only changes form. When a giant cloud of gas and dust begins to collapse under gravity, it's never perfectly uniform. There are always tiny differences, one side a bit denser, another slightly faster. Those small variations are enough to create a gentle twist. And as the cloud shrinks, that twist grows stronger. Just like a skater spinning faster when pulling her arms in the collapsing cloud speeds up as its radius gets smaller. That's how stars and planets are born, not in stillness but in motion. This is the power of angular momentum, the cosmic law that keeps rotation alive. It's not something added later, it's something inherited from the moment matter begins to move. Once rotation begins, it resists change. There's no air in space to slow it down, no friction to stop it. So the motion continues, preserved for billions of years. Even the solar system we live in is a relic of that process. 4.5 billion years ago, it was just a swirling disk of gas. At its center, gravity pulled the densest region inward. That became the Sunday. The leftover material flattened into a rotating ring, and from that ring, the planets were born. Each planet kept its share of the original spin. That's why most of them orbit in the same direction, and they rotate along nearly the same plane. This solar system is literally the fossilized memory of a cosmic rotation, but not everything spins the same way. Some planets tilt, some even roll sideways. Uranus, for example, spins almost on its side. This is probably because a massive collision long ago knocked it over. Venus spins backwards compared to most planets. This is a sign that violent impacts or tidal forces once rewrote its motion. Yet even those chaotic events never erased angular momentum. They simply redirected it. Rotation isn't just common, it's inevitable. Anytime gravity gathers matter, rotation naturally emerges. The only way to stop it would be to perfectly balance every motion in every direction. This is something nature has never done, not even once. So from the smallest dust grain to the grandest galaxy spin isn't an accident of physics. It's a built-in feature of how the universe organizes itself. The cosmos doesn't need a reason to spin. Spinning is the reason things exist the way they do. Once something starts to spin, it changes everything. Rotation isn't just a background detail. It decides how things look, behave, and even survive in the universe. Spin is one of the most creative forces in nature. Let's start small. When a forming star begins to rotate, that motion keeps it from collapsing completely under gravity. Without spin, gravity would crush everything inward until it became a single point. But rotation creates a delicate balance, a kind of invisible support. It flattens the gas into a disk around the newborn star, and that disk becomes the birthplace of planets, moons, and asteroids. So spin doesn't just stabilize stars, it literally builds solar systems. The same rule shapes the planets themselves. Earth, for example, bulges slightly at the equator. It is about 43 kilometers wider there than from pole to pole. That's what happens when a planet spins at more than 1,600 kilometers per hour. Centrifugal force pushes outwards, competing with gravity's inward pull. Without that balance, Earth's surface, and maybe even its climate, would be very different. Spin also controls how planets live and die. Fast-spinning worlds have powerful magnetic fields. These are created by the motion of molten metal deep inside their cores. That magnetic field shields us from deadly solar radiation. It's one reason life on Earth can exist. Mars, by contrast, spins more slowly and lost much of its internal heat early on. Its magnetic field faded, and the solar wind stripped away its atmosphere. Two planets, same star, but rotation decided their fate. Now scale that up. Stars too are shaped by their spin. A slow spinning star burns steadily for billions of years. A rapidly spinning one becomes turbulent and unstable. When it runs out of fuel, that spin can tear it apart. It collapses into one of the most extreme objects in the cosmos, a neutron star. These stellar corpses spin hundreds of times per second. They fire jets of energy that sweep through space like lighthouse beams. We call them pulsars, and they're some of the most precise clocks in the universe. Their rotation is so stable that scientists use them to measure time itself. And when rotation reaches its absolute limit, when gravity overwhelms even that, we get the most mysterious structure of all, the black hole. A black hole doesn't just pull things inward, its spin twists space and time itself. It drags everything nearby into a swirling spiral known as frame dragging. In those regions, even light can't escape. It's the ultimate example of motion shaping reality. Spin builds stars, it protects planets, it sculpts galaxies, and even warps space-time. Every structure we see, every elegant curve of a spiral galaxy, every stable orbit, every shimmering ring, is the result of billions of years of spinning matter finding its balance. When we talk about the beauty of the universe, we're really talking about the art of rotation. The cosmos isn't still because stillness would mean collapse. Instead, it dances every atom, every planet, every star. All are locked in a rhythm of endless motion, and we're part of that dance, riding on a spinning world, circling a spinning star, inside a spinning galaxy, in a universe that might itself be turning. Everything that spins, spins for a reason. The universe doesn't waste motion. It follows rules, invisible, unbreakable, and astonishingly simple. The first is inertia, the tendency of any object to keep doing what it's doing. If it's still, it stays still. If it's moving, it keeps moving unless something stops it. That's why a spacecraft launched into orbit can circle Earth for decades. It glides endlessly through space, with no engine, no fuel, no resistance. In the vacuum of the cosmos, there's nothing to slow it down. Motion once begun simply continues. Then comes gravity, the quiet architect of everything that spins. Gravity doesn't just pull straight inward. It curves motion into orbits. When a planet falls toward a star, it doesn't crash head-on. Its sideways velocity bends its fall into a loop. That's why we orbit instead of collide. It's a constant tug-of-war between falling and flying away. The result is the graceful balance we call an orbit. But the rule that keeps the universe in perfect rhythm is the conservation of angular momentum. It means that the total amount of spin in a system can never be created or destroyed. It can only be passed around. A figure skater, a collapsing star, or a whirling galaxy all obey the same law. If something shrinks, it spins faster. If it expands, it slows down. The numbers always balance. This single principle links the smallest and the largest scales of existence. The same physics that governs the spin of an electron also governs the dance of planets and the swirl of galaxies. It's one universal language of motion. Even collisions don't break the rule, they just redistribute momentum. When galaxies crash together, their stars rarely collide directly, but their angular momentum blends, forming new shapes, vast elliptical giants. Each one is still spinning, still conserving motion. Every spin in the universe is a kind of inheritance. It is a gift passed down from one era of matter to the next. From the first atomic particles to the galaxies that light up the sky, nothing is wasted, nothing stops. Momentum simply changes form, from the swirl of a collapsing cloud to the spin of a planet, from the dance of a planet to the orbit of a star, from the spin of a star to the spiral of a galaxy. That's why after 13.8 billion years the universe is still turning. It is the same motion that began in the beginning. The same subtle imbalance that started everything is still echoing today. Every planet's day, every galaxy's rotation is a trace of that first movement. We live in a cosmos that remembers. It doesn't forget motion. It keeps it, transforms it, and recycles it. Like a cosmic engine that never switches off, it turns endlessly. It is powered not by mystery, but by the elegance of physics. Spin brings order to the universe, but it also brings chaos. The same forces that shape stars and planets can just as easily tear them apart. Because motion in space is never perfectly balanced. Every collision, every uneven pull of gravity creates tiny imperfections. And over billions of years, those imperfections grow into drama. Take Saturn's rings. At first glance, they look peaceful. They are thin, shimmering bands of ice and rock circling in perfect harmony. But look closer, and you'll see turbulence everywhere. Each piece of debris follows its own path, nudged by the gravity of nearby moons. Some chunks are drawn together, others are flung apart. The result is a masterpiece of balance born from chaos. It is a frozen storm of billions of fragments, all held together by rotation. The same principle drives far more violent systems. When two stars orbit each other too closely, their spins begin to tangle. Gas is pulled from one to the other, forming a glowing accretion disk. This is a whirlpool of matter spinning at incredible speeds. Friction within that disk heats it until it blazes with X-rays. That's what we see around black holes regions where spin pushes physics to its limit. A black hole that rotates doesn't just pull matter inward, it twists space itself. This phenomenon called frame dragging means that near a spinning black hole space-time is literally being dragged around with it. Nothing can stay still, not even light. Photons are forced to swirl, bending around an invisible axis of infinite gravity. It's motion-devouring motion chaos written into the fabric of reality. Even galaxies aren't immune. Their spiral arms look calm from a distance, but they are sites of constant tension. There are waves of gravity, gas collisions, and star formation all competing at once. Some galaxies spin so fast that their outer stars should fly off into space, yet they don't. That's one of the mysteries that led scientists to propose dark matter. This is an unseen mass providing the extra gravity needed to hold them together. Without it, the universe's spin would tear itself apart. Spin creates beauty, but it also tests the limits of stability. Too little rotation and gravity wins. Everything collapses inward. Too much, and the system shatters, flinging its material into space. The perfect balance lies somewhere in between, a razor's edge that nature somehow finds again and again. Even our solar system bears scars of that chaos. Craters on the Moon and Mars are the fossilized evidence of an age when orbits were unstable. Planets shifted and collisions were frequent. Yet out of that turbulence came the stable clockwork we see today. It is a reminder that cosmic order often rises from chaos, not despite it. Spin isn't a guarantee of harmony, it's a test of balance. Every rotating world, every orbiting star, walks the fine line between control and collapse. And that tension, that fragile equilibrium, is what makes the universe so alive. Most of the time, spin feels familiar. A planet turning a star, rotating a galaxy, swirling through space. But when you push spin to the extreme, it stops behaving like anything we know. It becomes something else, something that stretches the very rules of physics. Let's start with a neutron star. It's what's left when a massive star dies. The core collapses, crushing itself into a sphere only about 20 kilometers wide, yet heavier than our Sunday. That collapse squeezes its rotation tighter, forcing it to spin faster and faster. Some neutron stars rotate hundreds of times per second. Their magnetic fields are so strong they shoot beams of radiation from their poles. Each pulse we detect on Earth marks a single rotation. It is a cosmic lighthouse flashing with perfect rhythm. We call them pulsars, and they are the most accurate natural clocks ever found. Even the best atomic clocks on Earth drift more than these stars do. But neutron stars are only the beginning. Spin them fast enough and gravity wins the final battle. They collapse into black holes, and that's where rotation becomes truly alien. A black hole can spin at nearly the speed of light. At that point, the laws of physics warp. Space-time itself begins to twist. It is dragged around by the black hole's rotation in a phenomenon called frame dragging. It's not a metaphor. If you orbited a spinning black hole, space itself would be moving around you. It would carry you with it, even if you tried to stay still. Inside this region, the ergosphere motion is no longer optional. Everything must rotate even light. Scientists call this type a Kerr black hole, and it's one of the strangest objects in the universe. Its spin defines its very structure. If it stopped spinning, theoretically, the ergosphere would vanish and the black hole itself would change shape. But there's no sign that ever happens. In fact, every black hole we've detected so far spins. The fastest ones complete a rotation in less than a millisecond. At those speeds, the energy locked in their spin can rival the output of entire galaxies. Some astrophysicists believe that jets of plasma shooting out from black holes are powered by the black hole's rotation itself. These streams stretch thousands of light years, powered through a process known as the Blandford's-Narjek mechanism. Its motion transformed into pure energy. And beyond even that, there's quantum spin, the kind that lives inside the tiniest particles. Electrons, protons, and neutrons all have spin, but not the kind you can picture as a sphere turning. Quantum spin is intrinsic. It's built into their identity. It gives rise to magnetism, chemistry, and even the structure of matter. It's why atoms form the way they do. It's why the world is solid instead of collapsing into a blur of particles. Without spin at the quantum level, matter as we know it couldn't exist. So from the tiniest particle to the most massive black hole, spin defines everything. It shapes the visible and the invisible. It holds the universe together, and at its extremes it shows us where our understanding ends. Because when motion approaches the speed of light and spin begins to drag time itself, we realize something humbling. We realize that the universe doesn't just spin in space-time. It spins space-time itself. It's easy to say that everything spins. But how do we actually know? How can we be sure that planets rotate, that stars turn, that galaxies swirl through space? How can we know when we can't even see most of them up close? The truth is, we've been watching motion for centuries. And nature has been showing us clues all along. The first real proof came from right here on Earth. In 1851, a French physicist named Léon Foucault suspended a giant pendulum from the dome of the Pantheon in Paris. He set it swinging back and forth and left it alone. To everyone's surprise, the direction of its swing began to slowly shift. The pendulum wasn't changing. The Earth was as our planet rotated beneath it. The swing appeared to twist, completing a full rotation every 24 hours. For the first time, humans could see our world spin, not as an idea, but as motion itself. A few decades later, telescopes revealed that other worlds moved too. By tracking the shadows of Jupiter's moons, astronomers noticed how the planet turned. They watched sunspots drift across the solar surface. And they measured the Doppler shift of starlight, the changing color as one side of a star moves toward us and the other side moves away. From that subtle difference in light, we can tell exactly how fast a star spins, even from billions of kilometers away. In the 20th century, our tools became far sharper. Radio telescopes picked up the perfect rhythmic signals of pulsars. This proved that neutron stars rotate hundreds of times per second. Each pulse that reaches Earth is a heartbeat of cosmic spin. It's so precise that even the slightest irregularity tells us when a pulsar has collided, shifted, or slowed down. It is like listening to the gears of the universe itself. Then came space telescopes, Hubble, Chandra, Gaia, and now the James Webb. They don't just take pictures, they measure motion. Gaia, for example, tracks over 1 billion stars. It records their movements across the Milky Way with incredible accuracy. The accuracy is so fine that it can detect the subtle wobble of our sun as planets tug on it while orbiting. From those wobbles, we've discovered thousands of exoplanets, new worlds, each with its own spin and dance around its star. Even the rotation of black holes, once purely theoretical, has been measured. We measure it by analyzing X-rays emitted from the superheated disks of gas around them. Scientists can determine how fast the black hole must be spinning. Some rotate so quickly that the edge of space itself is dragged around at nearly the speed of light. The Event Horizon Telescope captured the first image of a black hole's shadow. It showed that its ring glows brighter on one side, a direct result of rotation bending light itself. It's not an artist's impression, it's physics caught in the act, and the evidence doesn't stop there. Gravitational wave detectors like LIGO and Virgo can now hear the spin of black holes and neutron stars as they merge. Each chirp in the data tells us how fast they were rotating before the moment they collided. We're not just observing light anymore, we're feeling the ripples of motion through space-time itself. From a swinging pendulum to signals across billions of light years, the message has never changed. Everywhere we look, every tool we build, every wavelength we observe, the universe keeps telling us the same thing. It's moving constantly, endlessly. And through that motion we've learned not only where we are, we have learned that we are part of something still in motion, a living, turning cosmos that never truly rests. When we talk about spin, we usually imagine rotation, something turning in space. But the truth is deeper. Spin is the hidden thread that ties the universe together. It links gravity, magnetism, light, and even the structure of time itself. Let's start small with electrons. Every atom in your body contains them, tiny particles carrying both charge and spin. That combination creates magnetic fields. In fact, every magnet from the one on your fridge to Earth's own magnetic shield exists because of the alignment of countless spinning electrons. Without that microscopic motion, magnetism wouldn't exist. Your compass wouldn't work. Solar winds would strip our atmosphere away. Spin is what stands between us and cosmic radiation. But spin doesn't just protect us, it organizes the universe. The way electrons spin determines how they arrange themselves in atoms. It determines how chemical bonds form and ultimately how matter behaves. If the rules of spin were slightly different, chemistry as we know, it would collapse. Stars couldn't fuse elements. Life itself wouldn't have structure. Now scale that up. Spin also drives electric currents and planetary magnetism. Deep beneath our feet, molten iron moves and swirls as Earth rotates. This creates the geodynamo, a self-sustaining magnetic field that shields the entire planet. Jupiter's rapid rotation generates a magnetic field so enormous it stretches millions of kilometers into space. It forms invisible wings of plasma that trap radiation and sculpt the planet's glowing auroras. Spin turns motion into magnetism, and magnetism in turn shapes the motion of matter. It's an endless feedback loop, a cosmic handshake between energy and movement. Even light itself, the fastest thing in existence, has part of its nature to spin. A photon doesn't spin like a ball, but it carries intrinsic angular momentum which gives it polarization. This is the direction in which its electric and magnetic fields vibrate. That's why polarized sunglasses can block glare. And it's why astronomers can decode the structure of distant galaxies by studying the polarization of light reaching Earth. Spin leaves its fingerprint in every beam of light that's ever crossed the cosmos. And then there's gravity, the grand architect of motion. Einstein's general relativity tells us that mass curves spacetime. But when mass spins, it does more than curve. It twists. This effect, called frame dragging, means that rotation can literally drag time along with it. Near a massive spinning object like Earth or a black hole, time itself flows differently. The faster the spin, the stronger the twist. NASA's Gravity Probe B experiment confirmed this. It measured how Earth's rotation drags space-time by a few thousandths of a degree. This is a subtle, elegant proof that even our planet is slightly warping time as it turns. So from electrons to black holes, from the structure of atoms to the curvature of space-time, spin is everywhere. It doesn't just cause motion, it defines relationships. It links energy to matter, matter to magnetism, and motion to time. It's not an isolated phenomenon, it's a universal language. Every rotation, every orbit, every pulse in the universe is part of the same connected system. It is a cosmic choreography that ties all of existence together. Spin isn't just how the universe moves, it's how the universe communicates. Imagine the universe without motion. No planets orbiting, no stars turning, no atoms vibrating, only stillness. In that frozen reality, there would be no events, no change, and therefore no time. Time, at its most fundamental level, isn't something the universe has. It's something the universe does. It's the measure of change, the rhythm of motion unfolding from one moment to the next. And spin, more than anything else, keeps that rhythm alive. Every rotation in the cosmos, a planet turning a pulsar, flashing an electron spinning, is a way of marking time. A single spin equals a single tick in the universe's clockwork. The faster the spin, the faster that clock runs. Without these cycles, there would be no reference for before or after. Spin gives structure to time itself. On the human scale, this feels familiar. We measure days by Earth's rotation and years by its orbit around the Sunday. Even the oscillations of atoms, their internal spins flipping back and forth, form the basis of atomic clocks. These are so precise they lose only a second every 100 million years. Every tick of time we know comes from motion, from something turning, vibrating, or repeating. But the connection goes deeper than calendars and clocks. In physics, time and energy are intertwined, and motion, especially rotational motion, is one of the purest forms of energy there is. When something spins, it has kinetic energy, and as it loses that energy through friction, radiation, or collision, it moves toward equilibrium. That gradual loss of order, called entropy, is what gives time its direction forward. If all motion were to stop, entropy would stop increasing, and time as we understand it would freeze. That's not poetry, it's thermodynamics. The arrow of time we experience exists because energy is always moving. It moves from organized to disordered states. Spin is one of the key ways that process unfolds. It's how stars distribute energy, how galaxies evolve, and how the universe itself avoids collapse into static perfection. And then there's relativity, Einstein's revelation that time is not absolute. The faster something moves, the slower time flows for it compared to an outside observer. That means spin literally changes how time passes. A rapidly spinning neutron star, for instance, experiences time differently from the space around it. A spinning black hole twists both space and time into a single, inseparable fabric. In these regions, motion doesn't just mark time. It creates the conditions for time to exist at all. Every spin in the universe, from the smallest electron to the largest galaxy, is a tiny clock. Each one beats at its own rhythm. Together, they make the great symphony of time we all move through. So when you look up at the stars, you're not just seeing distance, you're seeing history in motion. Every turn, every orbit, every flicker of light is a story of time being written in rotation. Without motion, there would be no change. Without change, no time. And without time, the universe would be silent. Spin isn't just how things move through time, it's how time moves through everything. Every world begins with a turn. Billions of years ago, long before Earth existed, our solar system was nothing but a swirling cloud of gas and dust. It wasn't a calm place. It was turbulent, full of collisions, and everywhere gravity was pulling matter together. But even in that chaos, there was a pattern, a faint, collective spin. And that spin changed everything. As gravity drew material inward, the cloud began to flatten. It formed a massive rotating disk around the newborn Sunday. This wasn't coincidence. It was the natural outcome of angular momentum. When you take something vast and collapsing, it has to spin faster to conserve motion. That rotation prevented the disk from collapsing completely. It held the system together long enough for dust to stick, clump, and grow into planets. Each world that formed inherited its share of that original spin. That's why nearly all planets orbit the Sun in the same direction and along roughly the same plane. They are a flattened remnant of the disk that birthed them. Even today, billions of years later, the ancient rotation still defines the shape of our solar system. We are literally living in the fossil imprint of a motion older than Earth itself. Spin didn't just shape the orbits of planets, it built their character. When a planet spins on its axis, it creates day and night. It sets the rhythm for weather, wind, and temperature. Without spin, Earth's days would last forever. One side would be burning while the other froze in darkness. But rotation mixes light and shadow, distributing energy and making our world habitable. Even the tilt of that spin matters. Earth's 23.5-degree axial tilt creates the seasons. These are gentle cycles that allow life to adapt and thrive. If that tilt was smaller, our climate would stagnate. If it were larger, seasons would swing violently from extreme heat to ice. Our world's balance, its life-friendly rhythm, exists only because its spin is just right. And we're not unique. Every planet's rotation writes its own story. Mercury spins so slowly that one day lasts nearly 2 Earth months. Venus spins backward, its thick clouds locked in a perpetual slow-motion swirl. Mars spins almost like Earth, giving it familiar days, but its smaller size makes its climate more fragile. Then there's Jupiter, the giant that spins so fast it completes a day in just 10 hours. That furious rotation drives storms larger than entire planets like the Great Red Spot. The Great Red Spot is a vortex that has raged for centuries. Even moons bear the mark of spin. Our moon rotates exactly once per orbit around Earth. This is why we always see the same face. It's locked in a perfect balance, a cosmic handshake between gravity and rotation, known as tidal locking. Without that equilibrium, the moon's gravitational pull would constantly shift, tearing Earth's oceans apart. And spin doesn't stop at planets. Asteroids tumble chaotically. Comets twirl as sunlight heats their icy surfaces. And even dust grains in interstellar clouds rotate as they absorb light. At every scale, spin organizes matter. It turns chaos into structure and randomness into rhythm. Our world was not built in silence, it was sculpted by motion, the slow, patient rotation of dust and stone under the pull of gravity. Spin gave it shape, gave it weather, gave it seasons, and ultimately gave it life. Every sunrise, every ocean current, every heartbeat is part of that ancient rotation still unfolding. We live on a spinning world born from a spinning star in a universe that has never stopped turning. If the universe loves order, why doesn't everything spin the same way? At first glance, it almost seems like it does. Most planets orbit the Sun in the same direction. Most galaxies spiral clockwise or counterclockwise depending on how we see them. But look closer and you'll find small imperfections, tiny cracks in the universe's symmetry. And those cracks might hold the key to how everything began. Take our solar system. Nearly all planets orbit in the same direction. This is a memory of the primordial disk that created them. Yet 2 worlds defy the rule. Venus spins backwards, and Uranus rolls on its side. Its poles are pointing nearly at the Sunday. These are not accidents. They are scars, evidence of massive ancient impacts that changed their spin forever. The universe doesn't erase history. It keeps it in motion. But asymmetry runs deeper than collisions. When astronomers studied thousands of galaxies, they noticed something strange. They saw a tiny excess of galaxies spinning in one direction over the other. It's not much, maybe 1 or 2%, but it's enough to make scientists wonder. They wonder whether the entire universe itself has a subtle global rotation. If that's true, it could mean that the cosmos has a preferred direction. It could be a faint echo of the conditions from the Big Bang. Even at the smallest scales, nature isn't perfectly balanced. In the quantum world, particles and their mirror opposites don't behave exactly the same. This phenomenon, called parity violation, was first discovered in the 1950s. Physicists expected the laws of nature to look identical if you flipped them like a mirror. But when they tested it with decaying atomic nuclei, the results shocked everyone. Particles preferred one spin direction over the other. The universe, it seemed, had a handedness. That discovery changed physics forever. It proved that symmetry, one of nature's most beautiful principles, can be broken. And that breaking may be the reason we exist at all. If matter and antimatter were created in perfect balance, they would have annihilated each other instantly. This would have happened after the Big Bang, but something gave matter the slightest advantage. Perhaps it was a tiny difference in spin or a microscopic bias in how particles decayed. That tiny imbalance was enough to leave behind the atoms that form stars, galaxies, and eventually us. Spin may be the fingerprint of that ancient choice. It may be a subtle preference written into the laws of physics that tipped the scales toward existence. It's not just a mechanical motion. It's a clue to why there's something rather than nothing. So when you look at the spiral of a galaxy, remember that swirl might not be random. It could be the universe's own signature, a direction written into its very birth certificate. In a cosmos that values balance, it's the tiny imperfections, the small breaks in symmetry that make everything possible. If the universe had been perfect, it might never have existed. Perfection means balance, a stillness where every force cancels another. And in that silence, nothing could move, nothing could grow. The universe needed a flaw, a tiny deviation to begin. In the first moments after the Big Bang, there was no symmetry, no calm. There was just energy dense, chaotic, trembling with possibility. But within that chaos, some regions had slightly more matter. Some had slightly more spin, some with just a bit less. Those minuscule differences, 1 part in 100,000, were enough. They were enough to break the perfect mirror of the newborn cosmos. From that broken symmetry, everything we know began to unfold. Matter triumphed over antimatter. Gravity gathered the uneven fog of plasma into knots. Each knot spun a little differently, some clockwise, some counterclockwise, and those subtle twists became the seeds of galaxies. So imperfection, not perfection, is what shaped creation. It's what allowed energy to flow and time to move forward. If symmetry had never broken, the universe would have remained a flat, uniform sea of radiation. There would be no stars, no planets, no life. Stillness would have been eternal death. But because of that imbalance, that one small cosmic bias, the universe began to turn. Every star, every world, every atom we know is a ripple born from that first tiny asymmetry. It's the universe's way of remembering that perfection isn't fertile. Motion is. And motion was born not from order, but from the courage of chaos to be slightly uneven. Maybe that's the deepest truth written in the cosmos. That beauty is not symmetry, but the dance between opposites. Every spiral, every orbit, every rotation is the echo of that original imperfection. It is the imperfection that gave the universe permission to move. The universe didn't begin with peace, it began with imbalance. And in that imbalance it found direction. Imagine rewinding time back beyond galaxies, stars, or atoms. Imagine the instant when the universe was smaller than a grain of sand. It was a trillion times denser than the core of a star, an unimaginably hot energy condensed into pure potential. In that chaos, quantum fields rippled wildly. Tiny fluctuations appeared wrinkles in the fabric of reality itself. Each one was a surge of energy, a miniature whirlpool of motion. These weren't just random waves. They carried spin, microscopic twists in space-time, the universe's first rotational fingerprints. Then came inflation. In less than a heartbeat, the universe expanded faster than light. It stretched those subatomic eddies into cosmic vortices. Tiny quantum spins became vast swirls of matter and energy. Their imprints were frozen into the geometry of the cosmos. The first galaxies, billions of years later, would trace their shapes along those invisible currents. That was the first spin, the moment motion became destiny. It wasn't a rotation in space. It was the rotation of space. The laws of physics, gravity, electromagnetism, quantum mechanics were still crystallizing. But one principle was already in place. Motion cannot vanish, only transform. As the universe cooled, quarks spun together into protons and neutrons. Those combined into atoms, their electrons spinning in probability clouds. These were echoes of the first motion. Every atom in your body still carries that memory. It is a relic of the universe's original spin. If you could have stood there in that first instant when time began to tick, you wouldn't have seen light or heard sound. You would have felt motion itself twisting reality into existence. From that first turn, everything followed the swirl of galaxies, the orbit of planets, the heartbeat of life. The first spin was the moment when chaos learned to dance, and the universe took its first step toward becoming self-aware. Time did not arrive as a finished highway. It emerged as a path beaten by motion. In the newborn universe, change was the only certainty. Fields fluctuated, particles flickered into being, and space itself stretched. But change needs a measure, a reliable tick, or it dissolves into noise. Spin provided that tick. A rotation is a promise: begin here, return here. One turn defines a unit. From the first vortices, stretched by inflation, motion began to loop, and every loop gave time a foothold. Electrons carried intrinsic spin, a built-in rhythm that never winds down. Atomic nuclei precessed like tiny tops. As matter cooled and combined, these microscopic metronomes multiplied. They wrote a lattice of cycles into the fabric of reality. Yet time's arrow did not point forward merely because clocks began to tick. Direction required a preference. The universe chose its bias through a chain of subtle decisions. As the hot plasma thinned out of equilibrium, reactions froze into the memory of matter. Charge parity violation, the delicate asymmetry in particle decays, tipped the balance just enough for matter to endure. With each frozen choice, entropy increased. Energy spread from concentrated to diffuse, and the arrow of time lengthened. Spin made that spread orderly rather than catastrophic. Consider a collapsing cloud of gas. Gravity pulls inward. Rotation resists collapse, and the cloud flattens into a disk. Angular momentum does not vanish. It redistributes. What could have been a chaotic crash becomes a controlled spiral. The same logic played out across the early universe. Eddies diverted energy into orbits, orbits into rotations, and rotations into enduring structures. Motion slowed the rush to equilibrium, buying time for complexity to appear. Quantum mechanics added one more ingredient: selection. In the furnace of the first, second states interfered like overlapping waves. But as the cosmos expanded, interactions with the environment forced choices. Quantum possibilities decohered into outcomes. And many of those outcomes carried rotational character. Where a phase could wind it, wound. Where a field could twist it, twisted. Spin became the signature of decisions made and kept. Now imagine the first clocks coalescing out of that tumult. A pulsar is the end state of a massive star. But its idea was present from the start, a compact object whose rotation is so steady that its period can define time. Long before pulsars existed, the embryo of that possibility was alive in the rules governing spin and conservation. The universe prepared the tools of precision while it was still learning to cool. Time also learned to bend. Rotation does not only mark time, it shapes it. Where mass spins, space-time twists. Even in those early epochs' frame, dragging was written into the equations. It was a quiet guarantee that motion and time would never be separable. Later, around fast-spinning black holes that twist would become vivid. Clocks near the Hall would disagree with clocks far away, but the principle was ancient. To rotate is to edit the tempo of time. On human scales, we borrow this inheritance. We count days by Earth's spin seasons, by its tilt, and years by its orbit. Our most precise instruments measure the flips of atomic spin. All of our language for before and after rests on cycles. These cycles began when the universe first found the courage to turn. If time is the story of change, spin is the punctuation that makes the story readable. A world without rotation would still possess events, but they would smear into one another like ink without lines. With spin, events recur. Recurrence breeds expectation. Expectation invites memory, and memory is the foundation of meaning. When did time begin to turn? The honest answer is when motion learned to return. From the first closed paths in quantum phases to the grand orbits of galaxies, the universe taught itself to keep time. It did so by moving in circles. The arrow points forward because entropy demands it, but the ticks that let us hear that arrow are born of rotation, which brings us to a deeper question. If time can be heard, what does it sound like when the cosmos first starts keeping the beat? Before there were stars, the universe could sing. Not with air, not with strings, but with gravity and light. In the first 380,000 years, the cosmos was a hot plasma. Photons and baryons were locked together. Push that fluid in one place, and it rebounded in another. Compression followed rarefaction in a steady rhythm. These were not metaphors. They were real pressure waves, acoustic oscillations written across space. Every wave had a tempo set by the speed at which light and matter could communicate. The larger the region, the deeper the note. The smaller the region, the higher the pitch. Rotation joined the choir by adding vorticity. These were tiny curls that tried to twist the fluid as it rang. Most curls decayed, but not all. Where the cosmic medium could carry a hint of swirl, it did. And that swirl modulated the melody. Inflation, the great stretcher of scales, had prepared the score. It amplified quantum fluctuations and laid down phases with uncanny coherence. When the plasma began to sing, those phases ensured that distant regions were in step. They were like drummers hearing the same downbeat across a desert. The universe did not hum randomly. It performed a piece with recognizable motifs. We can still read the sheet music. When atoms finally formed and the fog cleared, the last light of that era set off on a journey. It was a journey across 13.8 billion years. We call it the cosmic microwave background. Frozen in its faint glow are the fingerprints of those ancient notes. They are hot spots and cold spots, peaks and troughs that match the overtones of a resonant cavity the size of the young universe. There is a deeper channel beneath that light gravity itself. Long before the plasma decoupled space was shaking, primordial gravitational waves, ripples in the geometry, raced outward at light speed. They carried no charge, left no trail of ions, and could pass through matter as if it were fog. Where they met the photon sea, they imprinted a subtle twist in the polarization of the light. This was a curl-like pattern that researchers are still chasing across the sky. Detecting those curls cleanly would be like hearing the opening bar of creation with our own ears. Spin does not merely accompany these waves, it powers their structure. A rotating mass distribution radiates gravity the way a struck bell radiates sound. In the early universe, patches that carried angular momentum tried to whirl, even as the fluid resisted. That struggle wrote sidebands into the spectrum. These were gentle distortions that later growth would translate into the preferred alignments of galaxies. It would also translate into the winding of the cosmic web. Listen closely to what the data say. The spacing of the acoustic peaks tells us the tempo of expansion. The relative heights tell us how much ordinary matter, dark matter, and radiation were present in the orchestra. The polarization patterns whisper about twists, rotations, and the faint hand of gravity waves. From a handful of harmonics, we can reconstruct the hall, the instruments, and the players. If you could stand in that young universe, you would not hear the way we hear. Your eardrums would find no air to shake. But your instruments would register a polyphony of oscillations. Density waves would be sloshing, curvature waves rippling, and rotational modes trying to catch hold. You would witness a chorus in which motion is both melody and meter. The song did not end when the plasma cleared. As gravity took over, waves broke into structures. Crests became clusters, troughs became voids, and the beat lengthened as expansion slowed the dance. Galaxies found the downbeats at the nodes of filaments where flows converged with a twist. Disks formed and stars ignited. Spin turned the score into architecture. There is poetry in this, but there is also restraint. The universe is not a free improvisation. It is a theme and variations played with crystalline discipline. Conservation laws keep rhythm. Initial conditions set key and tempo. Nonlinear growth writes the solo passages, and across the entire performance rotation adds grace notes that make the piece unforgettable. When we build detectors to catch gravity's faint tremors, we are not only chasing technical glory, we are tuning our ears to the first music ever performed. Each chirp from merging black holes is a late movement, an encore in a hall full of ancient echoes. To reach the overture, we must follow the harmonics back through the microwave background. We must follow them into an age when sound and spin were the same language. The overture is almost done. In the next act, the melody condenses into visible form. Ripples become rivers. Rivers braid into a web. The web winds itself into spirals. From the sound of creation, we step into its sculpture. And there, at the crossroads of waves and whirlpools, the first galaxies learned to turn. By the time the universe was a few 100,000 years old, its song had faded into silence. The light that once scattered in every direction now streamed freely, the cosmic microwave background. But the echoes of those early oscillations remained imprinted in matter itself. Tiny overdensities, just a few parts in 100,000, became the scaffolding of everything to come. Gravity took the stage. Where the density was slightly higher, matter began to fall inward. The collapse wasn't smooth. It carried a memory of motion. Every knot of gas and dark matter inherited a faint spin from the surrounding currents. This was vorticity seeded during inflation, amplified by turbulence. The universe had stopped singing, but it had begun to dance. As regions collapsed, conservation of angular momentum worked relentlessly. The same principle that makes an ice skater spin faster as she pulls in her arms applied on a cosmic scale. As halos of gas shrank, their rotation quickened. The first proto-galaxies were born not as still clouds. They were born as spinning storms of gas and dark matter. Computer simulations today like Illustris and Eagle recreate this process in exquisite detail. They show filaments of dark matter winding across the universe. These filaments intersect at nodes where galaxies ignite. Each filament carries angular momentum along its length. It feeds newborn galaxies with rotational energy like rivers feeding whirlpools. The pattern is astonishingly consistent. Galaxies don't just appear randomly distributed. They align with the cosmic web that birthed them. Their spins often trace the flow of dark matter. This is a silent reminder that even the invisible parts of the universe know how to turn. The physics behind it is simple yet profound. In an expanding universe, collapsing regions must shed excess angular momentum to settle. They do this through tidal torques, gravitational tugs between neighboring structures that twist each other as they form. It's a cosmic exchange of spin. One region slows while another speeds up. This ensures the total angular momentum of the universe remains conserved. Over billions of years, this dance of torque sculpted the familiar shapes we see today. Disks, spirals, bulges, bars, each is a frozen expression of angular momentum seeking equilibrium. The Milky Way itself is one of these survivors. Its stars are orbiting the galactic center like pearls on a spinning string. Each motion is a continuation of that first ripple in the early plasma. From the subatomic twist to the galactic swirl, the same principle repeats. Motion, once begun, persists. The ripples of creation became rivers of rotation, and those rivers over time carved the architecture of the cosmos. Every galaxy tells a story written in its spin. Some are grand spirals, their arms stretched like cosmic whirlpools. Others are smooth ellipticals, still turning but quietly. Their early energy was dispersed by collisions and merges. Each morphology is a fossil record of motion. Why do galaxies take different forms? The answer lies in the balance between angular momentum and gravity. A galaxy born with high spin retains its disk shape, its rotation counteracting collapse. Low spin systems, on the other hand, let gravity pull their material inward. This forms rounder, more spheroidal shapes. In this way, spin isn't just a property, it's destiny. Observations from the James Webb Space Telescope are beginning to glimpse this architecture at its origin. Galaxies only a few 100 million years old already show rotation. Some are spinning at over 200 kilometers per second. That's astonishing because in such a young universe there has barely been time for multiple rotations to occur. It means that spin isn't something galaxies acquire later. It's built in from the start, a direct inheritance from the primordial currents of the cosmos. But rotation doesn't just define shape. It governs how galaxies live and die. Fast-spinning disks channel gas along stable orbits. This sustains star formation for billions of years. When galaxies collide, their spins can either merge harmoniously or clash destructively. Aligned spins form vast rotating giants. Opposite spins cancel, creating turbulent spheroids that stop birthing stars. Angular momentum decides whether a galaxy thrives or fades. Dark matter again plays the invisible conductor. Simulations show that halos of dark matter spin. They guide the orientation and stability of the luminous matter within. The stars we see trace patterns drawn by forces we cannot see. They follow the hidden scaffolding of dark energy and dark matter. Even the elegant spirals of galaxies like Andromeda or the Milky Way are surface ripples on deeper, invisible vortices. The most beautiful revelation is that this pattern scales indefinitely. The same equations describe a hurricane, a galaxy, and a supercluster. Rotation provides stability amid chaos. It is a universal principle that governs every whirl of matter from storm clouds on Earth to the largest structures in the observable cosmos. So when you look at a spiral galaxy, its arms gracefully winding around a luminous core, you're seeing the geometry of motion made visible. Each curve is a trace of physics as old as the Big Bang. Each orbit is a note in the great harmony of spin. And though we measure it with telescopes and equations, its essence remains simple. The universe is not built on stillness, but on the quiet, eternal turning that holds it all together. Every spin in the universe is temporary, not because it fades, but because it gets shared. Galaxies, for all their grace, are not isolated dancers. They move through a crowded ballroom drawn together by invisible threads of gravity. And when two galaxies meet, their spins begin to speak. Collisions between galaxies look catastrophic, yet they unfold in slow motion. They are millions of years of gravitational choreography. From a distance, it seems as though they simply pass through one another. Their stars rarely collide head-on, but their motions, their angular momenta intertwine. Tidal forces stretch each galaxy like taffy, pulling out long arms of stars and gas that curve into glowing bridges. The result is not destruction, but transformation. In those colossal interactions, spin is rewritten. A galaxy's angular momentum can double split or even reverse. This depends on how it meets its partner. If two disks rotate in the same direction, their spins merge. The remnant becomes a massive, fast-spinning spiral or lenticular system. But if they collide in opposite directions, the violent tug-of-war tears their ordered motion apart. It leaves behind a rounder, slower rotating elliptical galaxy. Astronomers call this process violent relaxation, an ironic phrase for something that ends in stillness. Even so, nothing truly stops. The debris of these encounters doesn't vanish. It redistributes motion. Streams of gas collapse into new rotating disks. Some form rings, others form polar structures that orbit perpendicular to the old plane. In every case, angular momentum is conserved, never destroyed, only reimagined. Our own galaxy bears the scars of such encounters. The Milky Way is not a solitary creation. It was built from dozens of smaller galaxies consumed over billions of years. Astronomers can still trace the fossil trails of those mergers. They find streams of stars orbiting at odd angles, remnants of ancient collisions. Even now, the Milky Way is drawing the Sagittarius dwarf galaxy into its halo. It is absorbing its stars and stretching it into a ribbon of light that loops around the sky, and a far greater meeting lies ahead. In about 4 billion years, the Milky Way and Andromeda will collide. Simulations predict that their central black holes will spiral together. They will drag the surrounding stars into vast tidal arcs. Over billions of years, they will settle into a single enormous elliptical galaxy. This is an object astronomers have already nicknamed Milkomeda. The spiral arms that define our night sky will dissolve. But the total spin, the combined angular momentum of both systems, will remain redistributed across a new form. What may look like an ending is in truth a recycling of motion. Each collision mixes angular momentum like colors of paint. It is chaotic at first, but ultimately creates new shades of structure. This cycle of merger and rebirth is one reason the universe never stagnates. Spin ensures continuity. Every generation of galaxies inherits the momentum of its ancestors. These grand interactions even shape how galaxies evolve internally. As they collide gas funnels toward their centers, this feeds bursts of star formation and awakens dormant black holes. Those black holes spin faster as they consume matter, and their jets, powered by rotational energy, can stretch across hundreds of thousands of light years. These jets regulate the growth of their host galaxies. Spin drives creation, then restrains it. A feedback loop as elegant as it is violent. It's humbling to realize that even chaos follows law. Every distorted spiral, every glowing bridge between galaxies is the visible signature of angular momentum doing its work. It balances gravity's hunger with motion's persistence. Collisions may reshape galaxies, but they also remind us that rotation is not fragile. It adapts, transfers, and endures. When galaxies collide, they're not fighting, they're conversing, exchanging their stories of motion. And through that cosmic conversation, the universe writes its next chapter of rotation. Every galaxy spins, yet the visible matter alone cannot explain why it holds together. If we add up all the stars, gas and dust, their combined gravity is far too weak. At the speeds we observe, galaxies should fly apart. Their outer stars should be flung into the void like sparks from a wheel, but they don't. Something unseen holds them in its grasp. Something massive, silent, and everywhere. We call it dark matter. It does not emit light, reflect it, or absorb it. It does not collide, clump, or glow, and yet it outweighs everything we can see by a factor of 5. It forms vast halos around every galaxy, invisible cocoons of mass that extend far beyond the starlight. Without those halos, rotation would make galaxies unstable. Spin would tear them apart. Dark matter provides the anchor, the unseen counterweight that lets spin endure. The evidence is unmistakable. When astronomers measure the orbital speeds of stars within galaxies, they find a mystery. The farther from the center, the faster stars move. This is a direct violation of Newton's expectations. Instead of slowing down, the rotation curve remains flat. It is as if an unseen hand keeps the outer stars in orbit. That hand is the gravitational influence of dark matter. It holds the spinning disk together, the way air pressure holds a tornado's column intact. On even larger scales, dark matter is the architect of cosmic spin. In the early universe, its particles moved slowly. Unhindered by radiation pressure, they began to collapse into filaments long before ordinary matter could cool. As those filaments grew, they twisted, channeling angular momentum through gravitational torques. Normal matter, the baryons, simply fell into these spinning scaffolds. They took on the rotational energy of the dark structures beneath. Every galactic spin, from the smallest dwarf to the grandest spiral, is a visible echo of a dark rotation. It is a rotation that began billions of years earlier. Computer simulations reveal this hidden choreography. When scientists model the universe with and without dark matter only, the dark matter version gives rise to realistic galaxies. Without it, disks fail to form, and the few that do cannot maintain coherent spin. Dark matter doesn't just shape galaxies, it teaches them how to turn. Even more intriguingly, the orientation of galaxies' spins across the sky still carries a memory. It is a memory of those primordial dark flows. Large surveys like the Sloan Digital Sky Survey find subtle correlations. More recently, the Euclid and DESI missions have found them too. They find correlations between the direction of galactic rotation and the structure of the cosmic web itself. The pattern suggests that dark matter is not merely a static background. It is a dynamic participant, a kind of gravitational field that spins back. Some theories even propose that dark matter's nature is tied to spin at the quantum level. If it is made of ultralight particles, axions perhaps, their collective behavior could form macroscopic vortices. These would be rotating condensates on cosmic scales. Others imagine dark matter as particles with intrinsic spin that interact only through gravity. They would subtly influence how galaxies align and evolve. Whatever its form, its fingerprints are everywhere. Rotation endures. Without dark matter, there would be no graceful spirals, no stable orbits, no long-lived motion. Gravity alone cannot balance the energy of spin. It needs the invisible framework that dark matter provides. The universe's great ballet depends on unseen dancers moving beneath the stage. It's a reminder that most of what governs the cosmos lies beyond the light we can see. We live in a universe whose motion is written in shadows. It is a symphony performed by matter we do not yet understand. But its rhythm keeps every galaxy turning. And if dark matter is the stage upon which the visible universe spins, then perhaps what lies beyond it, dark energy, is the rhythm that drives the entire performance forward. If you could step outside the universe and watch it from afar, you would not see chaos. You would see rhythm. Across billions of light years, galaxies are not scattered randomly. They trace vast filaments of invisible matter. They are woven into a structure so intricate that astronomers call it the cosmic web. Each filament connects to others at luminous intersections. These are clusters of galaxies rotating around shared centers of gravity. And though each galaxy spins on its own axis, together they form a choreography. It is a choreography so immense it might as well be a symphony of motion. This web is the universe's grand composition. Gravity is its conductor and angular momentum, its music. The pattern of spin alignment across these filaments reveals that galaxies don't rotate in isolation. Their spins tend to line up with the direction of the filaments they inhabit. It is as if they are responding to a deeper cosmic current. It's as though the entire cosmos inherited a single rhythm from its earliest fluctuations. It is a faint echo of the turbulence that followed inflation. Astronomers have begun to measure this alignment directly. Large surveys like the Sloan Digital Sky Survey map millions of galaxies. More recently, the Euclid and DESI missions have done the same. They map the position, velocity, and spin direction. What they found is astonishing. Spiral galaxies near the edges of filaments often spin along the filament. Meanwhile, those near the dense nodes, the intersections tend to spin perpendicular to it. The universe appears to be winding itself like a colossal screw. It is turning energy and matter into a coherent rotating architecture. This phenomenon isn't just poetic, it's physical. The same tidal torque forces that gave individual galaxies their spin also acted on the vast filaments of dark matter. As matter flowed inward, it twisted those filaments, and the galaxies that later formed within them retained the direction of that twist. Its angular momentum on the largest scale imaginable. The cosmic web itself is turning ever so slowly under the influence of gravity and time. Even the polarization of light from distant galaxies seems to reflect this hidden symmetry. Photons stretched by the expansion of space carry a subtle memory of the direction they came from. They carry a polarization pattern shaped by ancient rotational flows. By studying these patterns, scientists can trace the earliest cosmic vortices that still echo through today's universe. If we could accelerate time watching the universe evolve in a few minutes, the sight would be mesmerizing. Filaments would be twisting, clusters merging, and galaxies spinning like notes in a melody. Each movement would influence the next. The expansion of space would act as the tempo. Gravity would be the drumbeat. Dark matter would be the bass line that holds it all together. The luminous galaxies, the visible notes, would shimmer, merge, and resonate. They would be a visible harmony born from invisible physics. This is why astronomers often speak of cosmic coherence. It's not mystical, it's mathematical. The laws of motion apply everywhere. And through billions of years of gravitational evolution, they've produced not randomness but resonance. It is a pattern that repeats across scales, from the smallest particle spin to the turning of superclusters. And maybe that's the universe's most elegant truth. Order and motion are not enemies. They are partners. Each turn, each orbit, each vibration feeds back into a greater design. So when we gaze through telescopes at galaxies billions of light years away, we're not just seeing light from the past. We're seeing the rhythm of the universe made visible. It is a silent symphony, still playing the song that began with the first spin. The universe has always turned, but at some point, that cosmic motion found a new expression. It found expression in chemistry, in molecules in life. Long before planets cooled or oceans formed, rotation was already shaping the invisible architecture of matter. Atoms do not sit still. Their electrons spin, not metaphorically but literally. Spin is a built-in quantum property, the tiny magnetic heartbeat of every particle. And it is this microscopic motion that makes chemistry possible. When electrons spin in opposite directions, they pair, forming stable bonds. When they align, they repel, creating magnetism. Every molecule in your body is defined by this dance of spins. It is an interplay of attraction and resistance, symmetry and asymmetry. But the story becomes even stranger when we look at chirality, the handedness of molecules. Some molecules exist in two mirror forms, one left-handed, one right-handed. They are chemically identical, yet biologically incompatible. Your amino acids, the building blocks of life, are exclusively left-handed. Your DNA spirals to the right. This bias, this microscopic preference, is one of the great mysteries of biology. Why does life choose one spin over the other? In the laboratory, when we synthesize amino acids artificially, we get equal parts left and right. But nature does not. Every cell on Earth obeys a single direction, a universal asymmetry. It is as if chemistry itself remembers the universe's original imbalance. Some scientists think the answer lies in cosmic spin itself. Polarized light from newborn stars, or the magnetic fields of supernovae, might have destroyed one molecular orientation more readily. This would have left a surplus of left-handed precursors drifting through interstellar clouds. Meteorites that landed on early Earth, like the famous Murchison meteorite, contain amino acids with this same bias. The seeds of our biological asymmetry may have been sown in the spinning clouds of space. Others suggest that fundamental forces like the weak nuclear interaction already broke symmetry billions of years earlier. In particle physics, left-handed neutrinos dominate the universe. This is a tiny clue that nature itself prefers one spin orientation. Perhaps that subtle quantum preference echoed upward through chemistry. Life simply followed the direction physics had already chosen. Whatever the origin, the result is profound. Life is not balanced, it's biased. And that bias is what gives it direction. A mirror version of Earth built from right-handed amino acids and left-handed sugars would look identical from afar, yet its biology would be incompatible with ours. Even our enzymes, the molecular machines that build and repair life, depend on the right kind of twist. Reverse that twist, and the entire machinery of biology grinds to a halt. It's a reminder that rotation once again decides fate. From galaxies to genes, spin separates what can exist from what cannot. Our very existence depends on this cosmic preference. It is a faint whisper of a symmetry that began billions of years before life itself. The DNA double helix, that elegant ladder spiraling through every living cell, is not just a symbol of life. It is a monument to motion. Each twist, each turn, is the echo of the universe's earliest rotations. It is translated into the language of biology, and perhaps that is the hidden poetry of existence. Life didn't invent motion, it inherited it. Every world spins, but not every world is alive. The difference often lies in what that spin creates. Beneath the surface, deep below our feet, far beneath the crust and mantle, lies a sea of molten iron and nickel. It is a planet's beating heart of metal. It churns and roils like a slow, fiery ocean. Its currents are driven by heat escaping from the core and by the planet's own rotation. From that restless motion, an invisible miracle is born: Earth's magnetic field. This field is not static. It is a living phenomenon of motion. As molten metal moves through, the core-charged particles create electric currents. Those currents generate magnetic fields, and the planet's rotation aligns them into a coherent global shield. We call this process the geodynamo. It is one of the most complex yet most elegant machines in the universe. It is a self-sustaining generator powered by spin. Without it, Earth would be defenseless. Our atmosphere would be slowly stripped away by the relentless wind of charged particles streaming from the sunday. Every flare, every coronal mass ejection would erode the air that protects us. The auroras that dance at the poles, beautiful curtains of light, are merely the visible edge of this defense. They are the battle scars of a planet that spins fast enough to survive. We don't have to imagine a world without this protection. Mars offers the perfect cautionary tale. Once it too had a molten core and a global magnetic field, but as the small planet cooled, its core solidified and its dynamo stopped turning. The shield vanished. Solar wind swept its atmosphere into space. It left behind a cold, dry desert where rivers once flowed. Its surface today is bombarded by radiation. Its sky is thin and silent. Mars spins, yes, but it no longer spins deep. Jupiter, by contrast, is a giant engine of magnetism. Though made mostly of hydrogen, its immense pressure turns the gas metallic near the core. Combined with Jupiter's rapid 10-hour rotation, this metallic hydrogen generates the strongest magnetic field of any planet. It is a field so vast it could hold 15 Earths inside. It funnels radiation into deadly belts, but it also creates auroras hundreds of times brighter than ours. This is a testament to how powerfully rotation can sculpt invisible forces. Even our moon bears the imprint of spin and magnetism. It once had a weak dynamo of its own, likely driven by tidal interactions with Earth. It was a magnetic echo that faded as the moon's core cooled. The frozen magnetic patterns on its surface are relics of that long-lost internal motion. They are tiny fossils of an ancient planetary heartbeat. For Earth, though, the heartbeat continues. Every day, our planet's rotation keeps the liquid core turning. It sustains the shield that makes life possible. And that shield does more than block radiation. It stabilizes our atmosphere, guides animal migration, and even shapes the behavior of our technology. Every compass, every satellite, every GPS signal is quietly tracing the lines of a magnetic field, a field born from planetary spin. It's humbling to realize that our survival depends not on something we can see. It depends on a motion we can only feel indirectly, the slow, unseen turning of molten iron miles beneath our feet. Spin gave us chemistry. Spin gave us magnetism. And together they gave us a home that endures. So when you watch the aurora shimmer across the polar sky, remember what you're really seeing. You are seeing the proof that our planet is alive inside. You see that deep within its heart, the universe's oldest rhythm, the rhythm of rotation, still plays on. Not too fast, not too slow. Our world spins at a pace that seems ordinary, one rotation every 24 hours. But that rhythm is no accident. It is the quiet balance that makes life possible. If Earth spun much faster, days would be shorter. Winds would roar across continents at hundreds of kilometers per hour, and the atmosphere would stretch into violent, unstable bands. Centrifugal force would push oceans toward the equator, flooding lowlands. This would leave the poles exposed and dry. Mountains would erode faster, storms would rage longer, and gravity at the equator would feel slightly weaker. This would be just enough to shift the delicate balance of air, sea, and land that sustains our climate. But if Earth spun more slowly, the opposite disaster would unfold. Days and nights would last for weeks. Under the long daylight, one hemisphere would bake beneath unending heat. The other would freeze in darkness. The atmosphere would struggle to circulate. This would create deserts of fire and continents of ice. The oceans might still move, but they would carry heat too slowly to rescue either side. Life as we know it, dependent on cycles of temperature, light, and darkness, would never have formed. Our 24-hour rotation is a compromise sculpted by time. When Earth was born, it spun much faster. A day lasted barely 6 hours. But over billions of years, gravitational tides from the moon slowed that rotation. The same friction that makes ocean tides rise and fall acts as a brake. It converts rotational energy into heat. Each century Earth's day lengthens by about 2 milliseconds. It's almost imperceptible, yet it means that long after we're gone, our descendants will live on a planet that turns a little slower. Its clock will be forever changing by the gentlest touch of gravity. That slowing paradoxically stabilized everything. A faster Earth would have torn its atmosphere. and crust more violently. A slower one would have lost its magnetic dynamo sooner. But this middle ground, this just right spin, gives us both climate and protection. It creates predictable rhythms day and night, wind and rain, wake and sleep. Spin set the tempo, and life evolved to dance to it. Our very biology is tuned to this rotation. Every living organism on Earth, from bacteria to blue whales, follows a circadian rhythm. This rhythm mirrors the planet's daily spin. Inside, every cell molecular clocks tick in harmony with the rising and setting of the Sunday. These cycles control when we eat, when we rest, and when we heal. If the planet's spin had been different, so too would be the rhythm of our chemistry. It's as if Earth itself wrote its rotation into our DNA. The spin of the planet became the pulse of life. Each sunrise resets the clock. Each sunset reminds us that the universe turns, and we turn with it. Astronomers studying exoplanets often speak of the habitable zone. This is the region where liquid water can exist. But there is another quieter requirement, the rotational habitable zone. A planet may be at the right distance from its star, but if it spins too quickly or too slowly, its surface may be uninhabitable. Spin defines not only the passage of time, but the possibility of balance. The Earth's rotation, its axial tilt, and the pull of the Moon combined to create a stability that few worlds share. They prevent chaotic wobbling, keep the seasons steady, and preserve an environment mild enough for complexity to thrive. It is a partnership forged over 4.5 billion years. Gravity, spin, and chance working in unison to create a planet that turns just right. So when you watch the horizon brighten each morning, remember that sunrise isn't merely the result of motion. It's the proof of balance, the fine-tuned spin that lets oceans breathe, clouds flow, and hearts beat. Our world's gentle rotation is not trivial. It is the perfect imperfection that lets life endure. Life on Earth does not merely exist within time, it was built by it. From the first cell to the first consciousness, every creature has lived under the slow metronome of a turning world. The rotation of the Earth, its axial tilt, its orbit around the Sun, these are not just motions of rock and gravity, they are the pulses that carved biology itself. When life began, the young planet spun faster. A day lasted only a few hours. The early oceans were in constant twilight. They were bathed in fierce ultraviolet light by day and plunged into long freezing nights. Primitive cells learned to adapt to these extremes. They developed molecular rhythms that told them when to protect themselves and when to divide. Those rhythms, simple chemical cycles at first, became the ancestors of what we now call circadian clocks. Even bacteria have them, tiny feedback loops of genes and proteins that oscillate with astonishing precision. They oscillate for roughly 24 hours, synchronized to the planet's rotation. In plants, these clocks tell leaves when to open stems, when to grow, and flowers when to release pollen. In animals, they regulate sleep, temperature, and hormone cycles. And in humans, they orchestrate nearly every process in the body. They control everything from the firing of neurons to the repair of DNA. Spin is the silent conductor behind this universal rhythm. But the influence of rotation doesn't stop at the daily scale. The axial tilt of Earth, about 23.5 degrees, creates seasons. These are periodic swings of sunlight and temperature that have sculpted evolution for hundreds of millions of years. The migrations of birds, the hibernation of mammals, the blooming of forests, and even the rise and fall of ice ages are all consequences of a planet that spins. A planet that spins not perfectly upright but beautifully tilted. That imperfection gives the world diversity. It forces species to adapt, move, or perish. In the fossil record, we can see this pulse imprinted in stone. Coral skeletons layered like tree rings record the number of days in ancient years. They show that Earth's spin has been gradually slowing over time. Hundreds of millions of years ago, a year contained more than 400 days. That means shorter days, faster rotation, and faster biological rhythms. Evolution itself has adjusted its tempo to match the slowing heartbeat of the planet. The moon too plays its part. Its gravitational pull not only steadies Earth's tilt but also stirs the tides that sculpted life's earliest forms. Every rise and fall of the sea was a whisper of time to the first organisms crawling onto land. In that rhythm of water and rotation, cells learned coordination. Muscles evolved to move in waves, hearts to beat, and lungs to pulse. Even our most intimate biological cycles are echoes of the ocean's tides, and through them they are echoes of the moon's slow pull on Earth's spin. If evolution is the story of adaptation, then time is the ink, and spin is the hand that writes. The cycles of day and night, of summer and winter, of tides and seasons, are not mere scenery for life's drama. They are the script itself. Some scientists now believe that intelligence, the ability to anticipate and plan, arose from this same need to predict periodic change. Brains evolved as pattern detectors, and the first pattern every organism had to learn was the turning of the world. To know when to hunt, to hide, to rest, to sense that tomorrow will come. Consciousness may itself be a byproduct of rotation. It may be the awareness of cycles within cycles. Our planet spins, and through that motion it teaches everything upon it to move, to adapt, to remember. The pulse of Earth is not measured only by its rotation. It is measured by the living systems that keep time with it. Every sunrise resets the clock of evolution. Every sunset prepares the next act of creation. And when you close your eyes tonight, you are in a sense returning to the same rhythm that began 4 billion years ago, the steady ancient turning of a world that spins just right. Every motion has a cost. Every spin, no matter how grand, eventually yields to time. The universe began in furious motion. Space was expanding faster than light matter, collapsing into stars, galaxies swirling into vast cosmic wheels. But energy spreads and order erodes. The same laws that gave rise to rotation also ensure that it cannot last forever. Angular momentum is conserved, but energy is not eternal in its usable form. Friction, radiation, and gravitational tides all steal a little from the cosmic dance. Stars slow as they lose mass. Planets drift as they trade angular momentum with their moons. Galaxies bleed their spin into tidal tails, and on the largest scales the expansion of space itself dilutes the rhythm of motion. Our own planet bears quiet witness to this slowing. Each century, the Earth's rotation lengthens by milliseconds. This happens as tidal friction transfers angular momentum to the moon. It pushes the moon a few centimeters farther away each year. 1 billion years from now, a day on Earth will last 30 hours, and the moon will hang smaller in the sky, a silent chronometer of our world's fading spin. The sun too is slowing. Its magnetic field drags against charged particles in the solar wind. This bleeds angular momentum into interplanetary space. Astronomers call this process magnetic braking, and it acts as the aging mechanism of stars. By measuring a star's rotation, we can tell its age. This technique is known as gyrochronology. The slower the spin, the older the star. Even the cosmos keeps time by how fast it turns. On galactic scales, collisions act as brakes. Each merger between galaxies redistributes their spin. It converts ordered rotation into random stellar orbits. That's why elliptical galaxies, the ancient remnants of countless mergers, rotate far more slowly than youthful spirals. They are the retired dancers of the universe, their energy spent, their grace replaced by stillness. But perhaps the greatest deceleration is written into the expansion of space itself. As dark energy drives the cosmos apart, gravitational interactions weaken. Clusters drift farther from one another, and the exchange of angular momentum between them dwindles. The cosmic web, once taut with tension, is relaxing. Its strands are slackening under the pull of eternity. One day, far beyond human imagination, when the last stars fade and galaxies dim to embers, the universe will enter its quietest age. Rotation will persist but faintly. Black holes will be turning in the dark. Atoms will be vibrating with the last shreds of heat. Each motion will be slower than the one before. Each revolution will be longer as entropy completes its endless work. It's tempting to call this the death of motion, but in truth, it is transformation. The energy that once built stars and galaxies will have diffused into the fine mist of space-time itself. Spin will not vanish. It will dissolve its legacy preserved in the geometry of the universe. Everything that moves leaves an imprint. Even when the last motion fades, the curvature it carved into space will remain. In that sense, nothing that ever turned will truly stop. The universe may slow, but it will never forget how to move. The stars will not shine forever. Even motion, beautiful and eternal as it seems, depends on fuel, and fuel runs out. For billions of years, nuclear fusion has powered the brilliance of the cosmos. Hydrogen fused into helium, helium into carbon and oxygen. This forged the elements that built worlds and life. But each reaction drains a little of the energy that keeps the universe bright. And as the stars age, their spin, once fierce, once full of balance, begins to slow. When a star like the Sun exhausts its fuel, its outer layers drift away into space. This leaves behind a dense glowing ember, a white dwarf. Though no larger than Earth, it contains half the Sun's mass. It still spins, but sluggishly, now cooling for trillions of years. It cools until it becomes a black dwarf, a dark frozen cinder in the endless night. No more light, no more warmth, only the memory of motion fading into stillness. Massive stars end differently. Their cores collapse under gravity's weight, spinning faster and faster as they shrink. It is the skater's trick played on a cosmic scale, but the pressure becomes unbearable, and the atoms themselves shatter. Electrons and protons merge into neutrons. They form an object so dense that a teaspoon of it would outweigh a mountain. These are neutron stars, spheres barely 20 kilometers wide, spinning hundreds of times per second. Some flash like cosmic lighthouses. Their magnetic poles sweep beams of radiation through space. We call them pulsars. Each pulse is a heartbeat of a dead star, still spinning, defying time itself. Even they will not last forever. As they radiate energy, their rotation slows, their beams fading into silence. Eventually, gravity wins one final time, crushing what remains into a black hole. A black hole is a region where even light cannot escape. Yet even their motion continues. Black holes spin too, dragging space and time around them in a whirlpool of gravity. Their rotation defines the shape of space-time itself. It bends the universe into spirals that never unwind. The fastest known black holes can spin at over 99% the speed of light. Their rotational energy is so immense that it can power jets stretching across galaxies. These are beams of plasma, millions of light years long. It's as though the universe stores its last reserves of motion in these silent engines. They are the final keepers of the cosmic dance. But even black holes are not immortal. According to Stephen Hawking's theory, they radiate energy through quantum effects. They radiate slowly, imperceptibly, shedding mass and angular momentum over unimaginable timescales. As they evaporate, their spin weakens. The last rotation in the universe may not belong to a galaxy or a star. It may belong to a black hole evaporating in darkness, turning one final time before dissolving into light. By then, the universe will be unrecognizable. No stars, no constellations, no warmth, only cold remnants drifting in a sea of black. Yet even in this quiet there is symmetry. It is a return to stillness that mirrors the beginning. The same physics that once ignited the stars will ensure their motion is never truly lost. Energy, spin, and time are transformed, not destroyed. The lights will go out, but the echo of their turning will ripple through space-time forever. And perhaps if the universe could dream, it would remember not its brightness, but the feeling of having once been in motion. In the end, everything will slow. Every star will fade. Every atom will drift apart. The universe will not die in fire, but in silence. When the final black holes evaporate, their last whisper of Hawking radiation will vanish into the cosmic night. No light, no warmth, no gravity strong enough to shape motion again. Space will continue expanding, cold, vast, and nearly empty, until distance itself becomes meaningless. But even then, spin will linger, not as motion but as memory. The curvature of space-time will still remember the vortices that once stirred it. Every particle that ever turned, every galaxy that ever spun, will have left an imprint on the geometry of reality. It will be a fossil record of movement in a universe that no longer moves. This is the heat death, the final equilibrium. Entropy has reached its maximum. There are no gradients left to drive change, no imbalance to fuel rotation. All temperature differences have evened out. All orbits have decayed. The cosmic symphony has played its last note, and silence has claimed the hall, and yet still the laws remain. Angular momentum is conserved, not destroyed. It is merely distributed into scales so vast, so diffuse, that it no longer has meaning to us. It is like a melody stretched beyond recognition. The rhythm of spin fades not by ending, but by spreading thin across infinity. Some physicists speculate that quantum fluctuations may still occur. These would be tiny ripples in the vacuum temporary twists of space and time. From one such fluctuation, a new universe might be born. Its own expansion would be ignited by the same instability that once birthed ours. If that ever happens, the first motion of that new cosmos, the first rotation, will not be truly new. It will be an echo of this one. Maybe that is the secret of creation. There is no final stillness, only intervals between movements. Spin never dies. It only changes scale. And if consciousness somewhere, someday, could witness that final age, it would see not tragedy, but continuity. Every cycle, every orbit, every turn was a note in a single unbroken pattern. From particles to planets, from atoms to galaxies, the universe spun itself into being. And now, it gracefully spins itself into rest. The last rotation may not be seen or heard or measured, but it will happen. Quietly, inevitably, beautifully, the final gesture of a cosmos that was born to turn. Nothing that ever moved is truly gone. Even when the universe falls, silent motion leaves behind a memory. It is woven into matter, encoded in form, and carved into the geometry of everything that remains. Every atom inside you remembers it. The iron in your blood was forged in the heart of a spinning star. The calcium in your bones was born in the collapse of a supernova, thrown into space by rotational fury. The very molecules of life, DNA, protein cells, all carry the mark of motion. They have a twist, a helix, a rhythm. You are made of memory. You are made of spin. When you lift your hand, when you breathe, when a thought sparks in your brain, each action is a tiny echo of ancient movement. It is a continuation of the same cosmic turning that began 13.8 billion years ago. From the swirl of galaxies to the pulse of a neuron, there has never been stillness, only continuity. Perhaps that is why consciousness feels like motion. It flows. It turns upon itself, reflecting, looping, remembering. Every idea you form is a kind of rotation. Matter thinking about its own movement. We are the universe's way of watching itself spin. And as we look outward past our skies, our stars, our time, we find that everything still turns. Electrons around nuclei, planets around stars, stars around galaxies, and galaxies around the unseen spine of dark matter. Each level of existence is built upon the last. Each rotation is a chapter in the story of becoming. The memory of motion is not stored in words or images. It is written in relationships, forces, balances, and orbits. Even when the lights go out, the structure remains. The eternal fingerprint of spin is pressed into space-time, and so when the final particle stops moving, if such a thing could ever happen, perhaps the universe will remember, not as sound or sight, but as symmetry, the echo of all that once turned. Maybe that's what it means to exist at all, to move, to leave a trace, to become part of a larger rhythm. The cosmos began as pure motion, a swirl, a vibration, a breath, and every form that followed was built from that first act of turning. We are not separate from it. We are its continuation. When we look up at a spiral galaxy and feel something stir inside us, that awe, that quiet recognition, it's because something within us remembers not in language, but in resonance. The universe spins, and so do we. And long after we are gone, long after stars and matter fade, that memory, the memory of motion, will remain. At the end of every journey, we arrive where we began, but see it for the first time. The universe began with motion, a flicker of imbalance, a single twist in a sea of nothingness. From that imperfection came direction, and from direction time itself. Everything that followed stars' atoms, life thought was born from that first act of turning. Now, after billions of years, that motion is scattered into 1 trillion forms. Some are grand like galaxies swirling across the cosmic web. Some are small like electrons spinning silently in your body. Yet every one is connected threads of a single spiral that never stopped unfolding. Perhaps this is what it means for the universe to remember. Not in words, not in memory as we know it, but through persistence, the refusal of motion to end. Each orbit, each rotation is a reminder that the story continues. We are the universe looking back at its own motion. Our curiosity, our longing to understand, is not separate from the laws that made us. It is those laws, matter thinking about motion energy, asking where it came from. And maybe that's why the question, why does everything spin, feels so profound? Because hidden within it is another question. Why do we move, learn, search, and create? Why do we turn endlessly toward meaning, as if trying to align with something larger than ourselves? In every galaxy, in every atom, in every heartbeat, the answer is the same. Because spin is existence. Without it, there is no time, no balance, no being. It is the gesture that keeps reality from collapsing into silence. If you could look beyond the final stars, beyond the last black hole into the darkness after time, perhaps you would still sense it, a pulse, a faint rhythm, the echo of the universe remembering itself. A whisper saying, I was motion, I became matter, I dreamed of life, and through life I learned what I was. And maybe when our own consciousness dissolves back into that cosmic sea, the universe will spin once more, not as a beginning but as a continuation. The circle will close, the silence will breathe, and in that breath everything will turn again. Time seems so simple. The sun rises, the sun sets, and days flow into nights. We build our calendars, our lives, and our history on that gentle rhythm. But behind this apparent simplicity there is a force invisible yet relentless. It is a force that makes everything we know possible. That force is spin. The Earth is spinning right now. Every second it carries us through space at over 1,600 kilometers per hour at the equator. You don't feel it, but the movement is there, steady, silent, unstoppable. It is this spin that gives us our 24-hour day, our sunrise and sunset. It gives us our concept of now and later. If that spin were even slightly different, so would our time. Shorter days would race the sun across the sky. Mornings and evenings would be compressed into quicksilver flashes. The equator would race ahead, the planet swelling a little more at its waist. and your weight there would ease by a whisper. Not enough to notice with a bathroom scale, but enough for physics to keep the score. Atomic clocks would hear it first. Time at low latitudes would slip a fraction behind. That tiny relativistic lag would grow with every extra turn per day. Air would try to keep up with rock. Jet streams would tighten, then snap into new lanes. The invisible hand that steers cyclones, the Coriolis effect, would press harder. It would sharpen curves into tighter spirals. Storms would spin up faster, travel farther, and carry more angular momentum in their bones. The tropics would breathe in shorter, louder gasps. The mid-latitudes would inherit a livelier parade of fronts. Seas would heap a little higher toward the equator as the bulge deepened. This would nudge shorelines, retune tides, and redirect coastal currents. And beneath the weather, biology would protest. Our bodies are written to a 24-hour rhythm. Hormones crest and fall, temperature drifts and neurons dim and brighten like a lighthouse lens. Halve the day, and you don't just rearrange calendars, you tug at the gears inside the skull. Sleep fragments and hunger arrives offbeat. Work-school conversation, all of it tries to march while the drumline changes tempo. We could fight it with shutters and LEDs, with shift schedules and pharmacology. But the sky would keep conducting, and life would learn the new key the hard way. Slow the planet, and the transformation runs in the other direction. The sun lingers. Noon does not blaze. It loiters, pouring steady heat into land and ocean for long, unblinking hours. Night is not a pause. It is a season. With more time to bake and more time to cool, the swing between day and night grows wide. Winds weaken because rotation gives them less twist. But the thermal contrast they must bridge becomes immense. Circulation reorganizes. Instead of 3 stacked cells in each hemisphere, vast Hadley cells swell poleward. They haul heat in long, tall loops. Monsoons stretch into epochs. Deserts expand under drawn-out suns. Frost bites deeper under extended stars. Hurricanes lose some of their familiar spin, yet heat has patience, and it finds other paths to violence. Slow-moving, sprawling storms could drown coasts simply by refusing to leave. The seas answer with their own inertia. Tides slip out of sync with human habit as the day lengthens and resonances shift. Coastal ecosystems that once timed their lives to a reliable cadence now misfire. Fisheries wander, bloom and spawn. Calendars tear loose. On land, agriculture meets a different clock. Crops bred to open and close their stomata on a tight schedule now face afternoons that last a lifetime. They now face nights that overstay. Farmers can chase shade with fabric and water with pipes. But the sky does not blink, and the soil remembers. In both futures the same truth speaks. Time still obeys the laws we trust, but our experience of it bends with the planet's turn. Faster spin means stronger relativistic drag on clocks at low latitudes. It means fiercer curvature in the pathways of air, and more kinetic energy stored in the day's machinery. Slower spin means gentler curves but harsher contrasts. It means a climate ruled less by swirl than by a standoff, with heat and cold staring at each other across a longer divide. And threaded through both is the human problem entrainment. We do not simply watch the day, we entrain to it. Cells keep molecular time, organs keep sectional time, communities keep civil time. Change the metronome and the orchestra stumbles. Then it retunes or it breaks. None of this is apocalypse. It is a reminder. Spin is not background decoration. It is the quiet engineer of habitability and the custodian of our inner clocks. The planet's rotation sets the length of a story we repeat every sunrise. Sleep, wake, work, eat, speak, dream. Speed that story up, and life breathes in quick, shallow phrases. Slow it down, and life speaks in long, heavy sentences. Either way, the punctuation changes. Shorelines redraw themselves by millimeters, and then by miles. Winds learn new corridors. Cultures invent new calendars. Science rewrites the algorithms that keep satellites honest and cities synchronized. And through every adjustment, the lesson stays simple enough to whisper to a child. The world turns and time turns with it. If the beat quickens, we hurry. If the beat slows, we wait. The melody, seasons, weather, biology, memory is arranged around that beat. Change the beat, and everything you can name changes its phrasing. Everything we've explored comes down to this. Spin is not just motion. It is the quiet metronome of the cosmos. From the slow turning of planets to the blazing fury of black holes. From the graceful swirl of galaxies to the invisible handedness of subatomic particles. Spin writes time into the structure of reality. When a planet spins, it sets the rhythm for every heartbeat, every sunrise, every story told beneath its sky. When a star spins, it sculpts gravity and light, pulling on space-time like a great conductor guiding an orchestra. When a galaxy spins, it shapes how entire clusters of stars breathe and evolve. And when a black hole spins, it reaches into the fabric of existence itself. It drags time into its vortex. But spin also lives in places we cannot see. Deep inside atoms, the spin of particles decides how matter stacks together. It decides how forces behave and how the arrow of time leans in one direction instead of the other. It is written into every decay, every collision, every whisper of the quantum world. This is why time is not something separate from motion. Time is woven into motion, and spin is the thread. Every clock, whether mechanical or atomic, is nothing more than a way to count cycles. A second is a number of oscillations. A day is a single turn of a world. A year is an orbit around a star. Time is built on motion, and motion almost always means spin. If you could somehow remove every rotation from the universe, what would remain? No planets turning, no stars twisting, no galaxies swirling, no electrons spinning in their quiet quantum rhythm. Perhaps time itself would lose its heartbeat. It might still exist as a dimension, but not as an experience. The flow we know would fall silent. Spin doesn't just shape time, it sustains it. It keeps the universe from being a still, timeless void. It gives us mornings and nights, beginnings and endings, memory and change. It is the cosmic clock that never stops ticking, not on a wrist, not on a wall, but in the fabric of existence itself. When you stand on Earth and feel nothing beneath your feet, remember this. The world is spinning, the stars are spinning, and the atoms in your blood are spinning. And with every turn, large or small, the universe whispers the same message. Time moves because everything does. Stand outside on a still night, and it feels as if the world isn't moving at all. The air is quiet, the stars look frozen, but nothing is still. Not the ground beneath your feet, not the galaxy above your head, not even the smallest piece of matter that makes up your body. Earth turns. The moon orbits. The sun spins around the heart of the galaxy. Every star in that spiral carries its own angular momentum. Every galaxy is part of a larger cosmic rotation. Even at the subatomic scale, the particles you're built from hum with spin, silent, ceaseless, absolute. The passage of time isn't floating somewhere outside of all this. It's emerging from it. The rhythm of rotation from the quantum up to the cosmic is the true clockwork of the universe. Every cycle, a planet's day, a star's spin, a photon's wave, becomes a heartbeat that defines how time unfolds. We build clocks out of gears, out of quartz, out of cesium atoms, but all of those are merely echoes of deeper, older clocks that the universe built long before us. Time as we live, it is carved out of motion, and motion itself is written in the language of spin. When we talk about time, we're really talking about turning. We are talking about the unseen pulse beneath everything, about a universe that never rests. The cosmos doesn't tick, it turns, and with every turn, it carries us forward, whether we notice or not. Spin is the secret clock, the one we never built, the one we can't stop. the one that keeps the universe alive.